Okay, let's proceed. Last week, what we were discussing is about, actually, these are the topics we have already discussed. We have discussed how to prepare the specifications, and then about the electronic spreadsheets. And last week and last few weeks, actually, we were discussing about programming, and that is quite a large chapter. And we have done several practicals, experiments, codings, developing games, various activities under that. And if there are any students who have missed the previous lessons, and if there are any students who have missed the previous lessons, my invitation is please go back, log into your LMS or the learning management system. Then in this learning management system, basically, using that, you can watch all the videos from the beginning. You will not miss anything, right? When you go to the LMS and access videos one by one, you can just refer to your LMS and learn everything from the beginning. You can watch all the videos, but oh, that's great news, Harisa. Congratulations, you got 92 marks in your examinations. Very good, right? That is what really needed. Really happy about you all. Okay, and please go through all the videos. And if you have any doubt, you can come back and ask when you are in the class, and you can even personally send me WhatsApps and ask any difficult lesson if you have, or any difficult area. Like I can then further explain and teach you how to do the particular task. Anyway, now my work is done. Actually, I have given you the idea, I have done enough practicals, given you the exercises, interactive practicals, lesson notes, everything. It's totally up to you to go and study them, right? If anyone joined later who missed the lessons, previous lessons, don't worry. Go to the LMS and watch the videos from the beginning. And if there are any doubts, come back and ask it in the class. Okay, now today's lesson is about microcontrollers. So this is interesting lesson and also a practical lesson like the previous lesson. We have to do a lot of activities. You have to commit this, right? So you can come to the class and like stay, just turn on your maybe your mobile phone, keep your mobile phone somewhere and listen to the class. But that is actually, that will give 10% of this class. You are not even using 10%. ඔයාලා පන්තියට ඇවිල්ලා audio on කරලා Zoom join වෙලා සද්දය අහගෙන හිටියොත්, just listening, you will only get 10% or less than 10%. සද්දය අහගෙන රූපත් බලාගෙන හිටියොත්, you will get 20%. You will listen to the class and you will watch the class. Still you will get 20%. එතකොට වැඩිපුර හම්බ වෙන්නේ මොකක් වුණොත්ද ක්ලාස් එකේ? දැන් ඇවිල්ලා බලාගෙන හිටියම දැන් වෙන online classes ගොඩක් තියෙනවනේ පුතේ. ඔයගොල්ලෝ යන්නේවත් ඇතිපා. එතකොට ගිහිල්ලා ඔයගොල්ලෝ කරන්නේ අහන් ඉන්නවා, බලන් ඉන්නවා. එහෙම online ඉගෙන ගත්තොත් 120යි ඔයාලට පන්තියෙන් හම්බ වෙන්නේ. අහන් ඉන්නත් ඕන, බලන් ඉන්නත් ඕන. You need to involve. You need to do this. You need to do the practical. You need to do this homeworks, practicals, assessment, participate in examinations, watch recordings, go to the LMS, refer them, refresh your knowledge, practice. Then on you will get the remaining 80%. එහෙම නැත්නම් ඔයාලට 180ම පන්තිය මිස් වෙනවා. නිකන් ඔයාලා අහගෙන බලාගෙන හිටියොත් ඉගෙන ගන්න 120ක් විතරයි. එහෙම ළමයි මම බලාපොරොත්තු වෙන්නේ නැහැ පන්තියේදී කියලා. මොකද එහෙම හිටියොත් වැඩක් නැහැ පුතේ. ඒක ඔයාට වැඩකුත් නැහැ, මට වැඩකුත් නැහැ, ඔයාලගේ අම්මලාට වැඩකුත්. Because you are not learning, you are just listening and watching. Better you watch a movie. පැය movie එකක් බලන්න. ඒක ඊට වැඩිය මම හිතනවා හොඳයි කියලා. ඔයාට අඩු ගන්න enjoy කරන්න පුළුවන්. ක්ලාස් එක පොඩ්ඩක් boring නේ. පැයක ෆිල්ම් එකක් දාගෙන බලන්න. That will be better. Right? If you are not participating, ඔයගොල්ලෝ කරන්න උත්සාහ කරන්නේ නැත්නම් ඒක කරන්න. ඒක තමයි කරන්න මේ. Okay, let me remind the previous like related lesson that we have learned in grade 6. Okay, in grade 6 we have learned about supercomputers, different category of computers actually. So under different categories we have learned about, there are multiple categories. The one is supercomputer, Supercomputer is the computer which provides service to many other computers. Actually, it can provide 10,000, more than that, even 100,000 users same time, simultaneously. එකවර usersලා ලක්ෂ ගානකට සේවාව දෙන්න පුළුවන් මේ සුපිරි පරිගණක supercomputers. We have learned about that. And Google like companies are using supercomputers as their servers. නේද? search කරනකොට හැමෝටම මේ results දෙන්න එකවර මිලියන ගානක් ලක්ෂ ගානක් search කරනවනේ පුතේ. ඉතින් ඒගොල්ලන්ට එකපාර result දෙන්න පුළුවන්. Google ලගේ තියෙන මේ සුපිරි computer එක. එකක් නෙමෙයි ඒගොල්ලෝ ගන්න super computer farm එකක්ම තියෙනවා. And not only Google, Facebook, like large companies, they are using supercomputers. And then the next larger one is this larger one is the next larger one is this. This can provide thousands of users service simultaneous mainframe. Useless of දහස් ගානකට පුළුවන්. And then this is all mainframe. පරණේවටත් mainframe කියලා කියනවා. ඒ දෙක පටලවා ගන්න එපා. දැන් මේ අලුතෙන් තියෙන mainframe ගැන කියන්නේ මේවා ඇත්තටම සුපිරි computers වලට දෙවෙනි ඊළඟ මට්ටමේ. ඊළඟට තියෙනවා mini computers. ඒවටත් පුළුවන් සාමාන්‍ය users ලා 100,000කට service දෙන්න. Right? 100,000කට service දෙන්න. ඊළඟට තියෙනවා workstation. ඒවත් users ලා කීප දෙනෙකුට service එක දෙන්න පුළුවන් එකපාර. 10 15 users can work with this. මේවා පොඩි companies වල service විදියටත් දා ගන්නවා එහෙනම්. Okay. Then actually after that only we have these other computers which are used by us basically. These are called our laptops, desktops, those computers. Right? Then we have these things. Okay, mini computer, microcomputers. Microcomputers maintain all these are microcomputers. You can see desktop, laptop, netbook, notebook, hybrid, tablet, smartphone, smartwatch, all are microcomputers. Now, in addition to that, we can see computing equipments in these devices. May device alas computing equipments. What are these computing equipments? Right? They are basically small boards, single board computers, single chip computers. Honey chip computers. Honey board computers. These computers are called embedded computers. Embedded computers. Okay. All these are embedded computers. Then these embedded computers, basically, these embedded computers are like robotics, even mobile phones. So we can divide them into two categories: single board, single chip. So now, actually, these are also computers. These are also accepting inputs, processing them. It has a memory, storage, output information. ඒවා මේකෙත් තියෙනවා නේද? computer එක තියෙන ලක්ෂණ තියෙනවා. හැබැයි මේවා අපි දකින්න normal computers වගේ it's not having a monitor, it's not having a keyboard, like we cannot see these things, but anyway we have some keys to input. A display maybe a right actuators to output, maybe print out. So likewise, these computers are also having different input output mechanisms as well as a processor as well as a memory. Okay. Now this is from grade 6. Let's come back to the grade 9. Under the microcontrollers, we are going to learn about this single board and single chip computers. These are also having central processing unit, a memory. Memory means two memories, like the temporary or volatile memory, like a random access memory, and a non-volatile, a permanent memory, which can store information, data for a long time. Long time storage eකට තියෙනවා non-volatile එකකුත් ඒ වගේම volatile එකකුත් තියෙනවා RAM වගේ తాවකාලික, right? And it has a CPU, central processing unit, and it has a peripheral devices, input output devices are also there. And not only that, it has a system clock which can be used to synchronize this. That means all the devices are working according to the timer, this timer. System clock කියන time එකට අනුව තමයි this central processing unit, memory, input output devices like peripherals, all are working according to a single system. Okay, it's like this. Okay, what time did you join class today, Anjana? Anjana, what time you joined the class today? Okay, as usual, Anjana's microphone is not working. Okay, Imaya, what time did you join the class? Anjana, sorry, Imaya, what time you joined the class today?
7 o'clock, sir.
7 o'clock, okay. Harisa, what time did you join? Harisa, what about you?
5, sir.
Same.
7:05, sir.
7:05. Rehansa, what time you have joined?
7:08.
Okay, 7:08, 7:12, 7:10, okay, different. But anyway, what time we are starting the class normally?
7:15.
Yeah, 7:10, 7:10, 7:15, that is the time that we are starting. Today we have started 7:15. Actually, all of us, the time 7 is common for all of us. අපි හැමෝටම 7 කියන time එක එකයි. If it takes time 7, it's common for all of us. අපි හැමෝටම එකම time. It's similar, the same time, right? We all work in according to a single clock, but we have different clocks in our home, but all are synchronized. Synchronized කියලා කියන්නේ හැම එකම එකම විදියට වැඩ කරා. එක time ඉන්න එක. To do that, the synchronization clock is needed. ඒකයි හැමෝටම එකම වෙලාවට වැඩ කරන්න තමයි දැන්. memory එක හැරෙනවා, CPU එක නිදි. එහෙම වෙන්න බෑ. The memory and CPU should wake up and work according to the same time the peripherals too. Therefore, there's a system. Okay, that's the need of system clock. Okay, so anyway, we are going to learn about these microcontrollers, and there are two kinds of microcontrollers. One is a single board, like Raspberry Pi. The other one is a single chip that's only having a chip. Chip is working as a computer here. A circuit board is working as a computer, including the chip and circuit board, both together working as a computer. Here, chip is working as a computer. Examples for this: washing machines, microwave ovens, solar lamps. But not only that, we saw a lot DSLR cameras, washroom dryers, hand dryers. එතකොට door, අර auto doors auto doors තියෙනවා. එතකොට අර මේ staircases තියෙනවා, automatic staircases උඩට යන lift. The lift එකක දොර ඇරෙන්නේ තට්ටුවට. මේ ඔක්කොම automated. They are having sensor systems. ඒ හැම එකකම sensors තියෙනවා. Automatically detect කරනවා. It will detect the state. So the lamp will detect when the light is. Washing machine will detect when the timer, basically when water is filled, washing machine will start its operation. When microwave oven, when it is like when a food is selected and it knows the time, it can identify the temperature, sense these things. So these microcontrollers are working with the help of sensors. Right here, this discussion, let's go back to the discussion that these students, what they are talking about. Just read it quickly. right? Then some here, the sun is up, yet the street lights are on. Isn't it a triumph to waste electricity these days? Yes. Okay. Then they are concerning about the lights. Lights are on, but still, when the sun is up, but lights are still on. This is ideal, I think, the ideal or typical situation in Sri Lanka. Anyway, they are talking about that. Okay. Then the boy suggests. So if there's a sensor to detect the sunrise, then this can be automated rather than assigning a person, right? This can be done for rail gates also. Right? When train is there, if a person is there and the person is not, maybe person on leave or something, sometimes these accidents can even happen. If rail gate is not properly functioning, it can be automated. Similar to that, this can be automated. Turning on and off lights. First, we have at least using lights, and then we can use train, like this rail gates. Okay, so then what are the sensors? What are the sensors? Sensors are, like we sense the environment. We sense the environment. We can see, we can feel, we can hear, we can smell, we can taste. Similar to that, the computers and these computing devices, basically those using the single board, single chip computers, can also get automatic inputs. Automatic inputs, remember, automatic inputs, auto inputs, not an input given by somebody. No need to enter that, okay, now sunlight is there. No need to input that. It should be sensed, automatically detected. To do that, the sensors are used. To do that, sensors are used. Okay, there are different sensors. Maybe the humidity of soil or water level, right? Or light level, or sound level, or whether there's a motion or not, the distance, all these things can be measured. And all these things can be measured and sensed. That is where the sensors. Actually, microcontrollers mostly take inputs from sensors, through sensors. Microcontrollers mostly take input through sensors. So the process is somewhat automated. Why? Because, okay, when a person comes, door will open. Or when a person moves, the staircase will start moving. Or when a person is there, the lift will not close. Likewise, if there are too many people in the lift, it will detect and tell it's too heavy. It's too heavy and cannot move. Likewise, it is necessary. Many places this automation is needed. That is where the sensors are used. Sensors will input and collect data, and it will feed to the microcontroller. Microcontroller will process that and generate the output based on the inputs. Okay, that is what here you can see the light sensor. When it's detected when light is absent, and it microcontroller will process the signal and it will turn on and off the lights based on that. Okay, now let's try to do this. Rather, we have discussed a lot. Yes, we have discussed how microcontrollers are there and what are the peripherals, why system clock, what is the synchronization. Okay, let's use them. So here they have suggested a few microbit Arduino Raspberry Pi. Today we are going to do that using Tinkercad. Okay, this website Tinkercad, we are going to use that. Okay, let's log into Tinkercad. All of you can do that. So now you have listened. Okay, 80%. Now the remaining 80% need to be done. Now you have already done only 20%. So there is a remaining part. Let's do that now. Okay, you can log into this Tinkercad. I will send the link. Please log into this. And who can share the screen? I will give you the chance to show the steps. Okay, can anybody share the screen? Then others can see the steps. Imaya, can you share the screen? Quickly, don't take much time. Oh, Rehansa. Come on, don't take much time, do it quickly. Respect others' time, please. Okay, Imaya, yeah, is there any problem? Screen sharing disabled, is it?
Yes, sir.
Yes, okay, okay, I have your permission. Sorry, my mistake. Can you do it now? Okay. Please go to the link, tinkercad.com. Click on the login button. Click on the login button. Yes, blue color login button. Select personal accounts. Personal accounts. Select sign in with Google. If you have Apple, you can sign in with Apple too. Select your Gmail account and proceed. That's it. It's a very simple set of steps. Okay, now you can see the Tinkercad screen, and here you can click on the create button, your designs under that create button, and select circuit. That's it. Okay, you are getting the surface now. Okay, anybody else need assistance, help, can share the screen. Very simple. Now I'm happy about most of you guys. So I think if I rank yourself within other students in the same grade in Sri Lanka, mostly you are in the top 5%. I'm sure mostly some of you are in top 1% or top 2% even. හරිද ඔයගොල්ලෝ ලංකාවේ ඉන්න ඔයාලගේ වයසේ අනිත් ස්ටුඩන්ට්ස් ලත් එක ගත්තාම බොහෝ විට මුල් 100ට 5 ඉන්නවා බොහෝ විට. සමහර කට්ටිය මුල් 100ට 1ෙත් ඉන්නවා. හරි සමහර අය මුල් 100ට 1ෙත් ඉන්නවා. Okay, anyone can share. Yes, who would like to share? Can do it now. Ithenia, right? You have already taken it. Okay, good. Anybody else who need assistance or help can share. ඕන කෙනෙක් share කරන්න පුතේ කමක් නැහැ. ඔයාලට උදව් ඕන නම් හොඳයි share කරන එක. එතන ඉගෙන ගන්න පුළුවන්. Gimaya, yes, you can. If you want, you can. Mod, you can. Osanda. No one. Anjana. කැමති කෙනෙක් share කරන්න පුතේ. එතකොට ඔයාලටයි වාසිය share කරන එකේ. කරගත්තා නම් කමක් නැහැ. උදව් ඕන නම් කොහොමද share කරන්න. Okay, I think all of you have done it, it seems. Okay, let's start then. Hari api patan gamu කමක් නැහැ. Since all of you have done, let's start. Okay, my first exercise is creating. Okay, first exercise is connecting LED, single LED. Let me erase everything first and begin from the start. I'm erasing this one also. Okay, first of all, search for Arduino. Actually, here in this stage, you can purchase Arduino if you want. ඔයාලට ඕන නම් ඇත්තටම මේ බෝඩ් එක සල්ලි දීලා ගන්නත් පුළුවන්. Now the rates are reduced. ඔය මම දැක්ක මේක එහෙම දරස් එකේම 2000ක් තියෙනවා Arduino. Okay, you can try for that. Therefore, you can try for that. They can එක අඩුයිනේ. ඒ ගාන අඩුයි ඔයාලට try කරන්න පුළුවන්. හරි. The price is little bit lower than earlier days. ඉස්සර වැඩි මේක ගොඩක් වැඩි වෙලා තිබිලා දැන් උන අඩු වෙලා තියෙනවා. You can try to buy that. Try to purchase that. Okay. Okay, take Arduino Uno board. එතකොට මේ ඕන අපේ kit එකකුත් තියෙනවා robotic small kit is there. You can, if you want, you can purchase that as well. ඒකත් ඔයාලට ඕන නම් purchase කරන්න පුළුවන් කාට හරි. That will be around 6,000 with some sensors and some input output controllers, peripherals, as well as a breadboard and LEDs. So that is a compost kit, pre-compost kit. You can buy that also. One that can make it 9,000 you can buy from us, or even buy from this what do you call art, like Daras, or do we know any place, right? Okay. Then let's start taking Arduino UNO board. It's this. Oh, yes, yes, you can use that Panium, of course. Is it still working? Good, no? Right, it's again, වැඩක් කරගෙන නෑ මම හිතන්නේ පිච්චෙනවා ගොඩක් projects එක ඒවා try කරාම. That Panium is saying that he can use his brother's one, which I have sent 1 year ago, means you have not used it that seems. Otherwise, if you have used that, it should be burned. ටිකක් දෙතුන් පාරක් වල පාවිච්චි කරලා මෙහෙම ගොඩ කල් use කරන්න පුළුවන් සමහර ඒවා. හැබැයි ඔයාලගේ accidents වෙනවනේ. ඒ accident වෙලාව නෑ පරිස්සම් කරලා වල ගොඩක්. හොඳයි. You can use that. Okay. Let's identify what are they. You can see these are the ports, pins that you can connect. And then you can see the GND, which is ground. Then you have the digital pins 0 to 13. And some analog pins also. A here, may A0, A1, A2, analog pins up to A5. And voltage in will give the current. And then GND another ground, 5 voltage out and 3.3 voltage out, reset, input output ref, and all these things are there. And there is a built-in LED, it's a built-in LED, and TXRX also indicators, and reset switch, all these things are there. So we'll learn one by one later, but for the moment I just need to connect an LED. To do that, I will search for LED and I will take small LED, this one, and I will connect. There's the long end and short end. Long end can bigger at the method anode. Short end is smaller side, right? It is cathode. Long end is the positive. Long end is positive. The short end is negative. Short end you have to connect it to the GND pin, whereas the long end you can connect it to any of these digital pins. I'm connecting it to pin number 12. You can connect to any of these. Okay, this is what my circuit is. I hope everybody can see. Please do this now and let me know once you are done. Okay, then the coding part. Let's go to the code. It's easy. You have already done that. Go to the code. And here you can see set built-in LED to high and built-in LED to low. When you play that, when you start the simulation here, start the simulation, you can see it will turn on this LED, built-in LED. This is actually connected to the pin number 13. While 13 volt connect kala tibbana මේ LED එකත් on වෙනවා. Let me show that. If you have connected this pin to 12, 13, now 13 connect karana, when the built-in LED is on, this will also be turned on because 13 is connected to the built-in LED. You can see that. But we have unfortunately or fortunately connected this to the number 12 now. Therefore, we have to code it. D12. We have to code it. Code that. Remove this. And keep this. Remove this as well. Keep this. Then set pin 12 to high. Set pin 12 to low. Set pin 12 to high. Set pin 12 to low. Now let's play this and start the simulation. Now we can see it's turning on, turning on. High is where turn on. Wait 1 second, it will wait 1 second in the high mode. Low is where you turn off. Wait 1 second, after that will turn off and keep it for 1 second. Okay. Okay, if you want to see, stop the simulation. If you want to see the code, you can go to the blocks plus text. Here, from here, this blocks is there. From that, you can see that blocks plus text. Then you can see the C++ code. Okay, when you change this, okay, so let's change it to 0.1. Here also 0.1. It's changed into 100 here. 100 milliseconds. 0.1, 100 milliseconds. 100 milliseconds means 1/10 of a second. It's faster. Now let me run the simulation. You can see the bulb is, you can turn it on and turn it off, will happen very fast. Because of this problem mark, you can see, because why the problem mark comes, because it gets more current than expected. The potentiality is there to turn, like burn the bulb, but it will not burn, don't worry. It's anyway manageable, but getting more than the expected. That is why this problem mark comes. If you want to really reduce it, you can add a resistor. Let's go to the resistor, get a resistor, change, you can change this to ohm, and like put maybe 50 ohms will be enough. Just connect it through a resistor. Then this problem mark will not. I have added 50 ohm resistor, that is enough to start. Let's start now, and you can see, start the simulation. Oh, still the it comes. Will be 100 ohm. Okay, it solve the problem. 100 ohm has solved this. Okay, please do this now. Let me know once you have finished. Right, once you have finished, please let me know. You have a small task. I will give you 3 minutes. What you need to do is you need to create this as a VIP light. That means use another light. Red, and you can connect another blue one. You have to interchange the turning on process. Like you have to change, like one time you have to turn on the red bulb, the other one, then blue, then again red, then again blue, red, blue, red, blue, red, blue, red, blue, like interleaving way. You need to turn on both bulbs. When the red is on, blue need to be off. When blue is on, red need to be off. Can you do that? Within 3 minutes, can we do that? And you can share the screen once you have finished. Thisa's one is okay. Rehansa, have you done? Imaya? Athenia? Okay. Only this red. I need red and blue both. I need red, blue both. Monday. VIP light red, blue. Take another one, another LED, change the color to blue. You can connect the same way. You can take a duplicate of this or take a resistor, change the resistance to 100 ohms. 100 ohm. 100 ohm resistor. Connect this to anode and connect this to maybe number 6. Connect this to GND, same GND. Here, GND, done. Go to the code, and now you can say here set pin here 6. You can set the 6 to low. And here set pin 6 to high. Method the 12 high with the 6 low, method the 12 low with the 6 high. That's it. Easy. So let's remove the code, start simulation, and you can see. They come because you need to slow down this. Let's put one here and one here. That is basically 1000 millisecond, 1000 millisecond. So let's go back, start the simulation. Now you can see. Okay. Third, 4 with the 5, 6 with the I rate, 8 with the rate, 10 with the rate, or even not 12 with the 12, 14 rate, 16 rate, 18 rate, 19, 10, 23, 25 blue, 27 blue, likewise. We method time in it. Synchronization the timer, and you can see it. Okay, do it, and code will be something like this. Let's remove the text part and just keep the block part only, and you can see the code like this. Okay, you can try it now. It's not difficult, it's easy. Try it now. Okay, Pute, I think with that we can stop for today, and let's discuss the remaining part next week, right? And good night. See you all next week. Bye.
Good night, sir.
sir.